This video is not meant to be an extensive review of anatomy and physiology, but rather we are going to have a look at our organs from a weight loss point of view. After all, the vast majority of our caloric expenditure on a daily basis comes from the workings of our organs, no matter how much fat you are carrying essentially around. So I think it's important to take some time to understand how everything fits together. And the other reason I think it is important to understand this is because a lot of people on a long weight loss journey tend to feel angry at their bodies. They tend to feel confused, and they tend to feel let down that despite their best efforts and despite their hard work, their weight loss happens on a very slow rate. So taking some time to understand the workings of our organs from an energy essentially perspective, I'm hoping it will help to foster a relationship of understanding, a relationship of appreciation, and a relationship of empowerment once you understand how things work. But most importantly, it will foster a relationship of acceptance of the things that we can and we cannot change in our bodies. And it will help you work with your body rather than fight it, essentially, to try and lose weight. After all, losing weight is something that the body is not really designed to do. In fact, it is designed for the exact opposite. Now, the starting point of this video is going to be from the absolute basics. So, the human body is composed of many organs. And what we tend to forget is that for the vast majority of the time, we do not have any control over them. For example, you cannot order your heart to pump faster. You cannot order your liver to produce more bile. You cannot order your gut to speed up its digestion time. All of these organs, they run on predetermined genetic, essentially, protocols that will activate and inactivate according to the environment essentially around it. But there's one thing that all organs agree on, and that thing is that they should function at the lowest possible rate to conserve energy, unless the need arises for them to essentially speed up. And that's the same for the heart, the liver, our intestines, all of our organs essentially. They always function at the lowest possible rate to achieve the goal that they are meant to achieve.
So these are the main organ systems. Organ systems are a group of organs that all share a common general function. For example, the cardiovascular respiratory system is comprised mainly of the heart, blood vessels, lungs, and airways. They all share the common goal of providing the body with oxygen and ridding the body of carbon dioxide. The heart pumps at a rate and force of contraction that is adequate for the demand placed on it. If oxygen demands go up, the heart speeds up. Once we rest, it slows back down after a period to conserve energy. Same thing goes for our blood pressure. During physical activity, it will spike to quite high levels to improve circulation to the muscles, and then it goes back down once we rest. The gastrointestinal system is comprised of the esophagus, which is the food pipe connecting the mouth to the stomach, the small intestines, the colon, liver, and the pancreas. Together, they are responsible for digestion, absorption, and processing of food. The spleen is part of the digestive system too, but it functions more as an immune organ filtering the blood. Just like the heart, this multi-organ system has a basal function rate where the liver produces bile at a certain level, the intestines contract at a slow rate if they don't have any nutrients inside them, and once we eat, the whole system ramps up its function. The stomach starts churning the food inside it to break it down, the intestinal contractions speed up, the liver starts producing a large amount of bile, and other digestive enzymes. The pancreas, the colon, the immune cells in our intestines, and the liver. The food gets absorbed and goes to the liver for further processing. It's a big orchestra that requires a lot of coordination and indeed a lot of energy. And once it's finished, everything slows back down, all to conserve energy. The genitourinary system takes care of filtering the blood. It regulates various salt levels and helps regulate blood pressure too. It is also responsible for reproduction. It is comprised of the kidneys, ureters, which are the urine ducts connecting the kidneys to the bladder, and the urethra, in addition to the reproductive organs. Blood flows through the kidneys at a certain rate, which goes up considerably during physical activity. And everything slows back down again to conserve energy once it is all over. The uterus in women goes through monthly maintenance, and once pregnancy happens, as it starts to grow, genitourinary systems in women send a cocktail of hormones that change almost all other systems. The heart pumps harder, the volume of blood expands, the kidneys work harder, all to support the fetus. And then after delivery, everything slows back down again. It's a huge energy expenditure on the mother, one that requires women to be masters of energy management to survive. The immune system is comprised of the bone marrow, where white blood cells, which are our defense cells, are essentially made. Then they further specialize in their function. Other involved organs include the thymus, which is a gland behind the chest bone, and lymph nodes. The intestines, liver, and spleen also play an important part in the immune system. Now, just like the previous organ systems, it functions at a basal low rate, and it ramps up and adapts as the need arises. So certain parts will become more active during, for example, infections. In fact, it further ramps up depending on what type of infection there is, being it bacterial, viral, fungal, or parasitic. Furthermore, other parts of the immune system deals with injuries. It's not that the whole immune system ramps up. Only the necessary parts for the challenge presented will ramp up. Then everything will slow down again, all to conserve energy. Now, the musculoskeletal system is mainly responsible for providing structure to the body and allow for locomotion or mobility, essentially. It is comprised of the skeleton, muscles, cartilage, tendons, and ligaments. Now, our bone density can change depending on the challenge it is presented with. We all have a basal bone density that is enough to allow us to do the things we want to do in our everyday life. This basal level differs from person to person, but there is one thing that is common between all of us. Our bones will become stronger and denser if subjected to certain loads. They will only get stronger if such a challenging load exists. It's like the body has to be convinced that it is worth spending energy on it, that our survival requires it. At that point, the body will go ahead and spend energy on adapting the bone to be able to handle a bigger load. Now, the endocrine system is comprised of all the major glands that produce hormones. This includes the pituitary gland, the thyroid gland, the parathyroid gland, adrenal glands, pancreas, reproductive glands, and fat cells as well. It is worth noting that adipose tissue or fat cells do in fact produce hormones, mainly estrogens, but also hormones that affect appetite and energy expenditure as well. Another thing to point out is that many endocrine glands are controlled by the brain. Now, the last system we will talk about is the nervous system. The brain, the spinal cord, nerves that span the whole body to every organ, and the sensory organs such as the eyes and ears. It is important to note that all organ systems are either directly or indirectly controlled or affected by the brain. For example, stress of any kind, causes the hypothalamus in the brain to initiate a cascade of events, which leads to the adrenal glands, which are located just above the kidneys, to produce cortisol. This prepares all systems for a flight or fight response. So blood pressure goes up to improve nutrient delivery to the muscles. Sugar and fatty acids are mobilized from the stores into the blood to be available for use in muscle tissue. Blood is diverted away from the systems not related to the fight or flight response to increase blood flow to the muscles. Things like the skin and the gastrointestinal organs are such examples. Even the immune system changes to prepare for tissue repair in case of external injury. Now, all this is not a problem, or even it is beneficial if it happens for a short period, such as, for example, when a dog barks at you on a morning walk. However, imagine if this stress response is secondary to mental stress that is chronic, meaning it is there day in, day out. It's nice to see that the latest guidelines for blood pressure management started recommending stress management as a useful therapeutic option.
Now, it's important to understand that our organs are not functioning at a constant, steady, preset rate, but rather they are constantly changing. And they change according to the environment, according to their own function, according to the body's function, according to the environment around our bodies as well. And once we appreciate that, it gets easier to understand why, when we calculate our total daily energy requirements in calories, or even when we measure our caloric basal metabolic rate using some fancy basic equipment, that number only holds true at that point in time in the environment that we are currently in. So if that environment changes for any reason, then a lot of the organs' energy expenditure is going to change as well. So let's say you didn't essentially sleep well, or you had a meal a couple of hours before, or you were emotionally as well upset. Any number of factors could drastically change the energy expenditure of certain organs. Now, it's important to appreciate that our organs are not functioning at a constant state, but rather they are functioning at a constant state of flux. So they're always essentially changing. They're always adjusting, they're always evaluating, they're always micro-adjusting according to the environment around them, according to their function and the body's general function as well, and the general environment that the body is in. And any number of changes could make drastic changes to the function of our organs. And that includes the energy expenditure of these organs. So it gets clearer now to understand how tricky it is to actually evaluate the caloric expenditure of our body. Using a formula or using even a fancy machine to figure out our basal metabolic rate. All of these things are going to give you a number which holds true at that point in time under those environmental circumstances around you. And if any factor changes, then that number changes.
Now, dividing the organs into organ systems can get a bit confusing sometimes, because in reality, all organs functions together to achieve certain goals. It's sometimes easier to divide the organ systems in terms of goal functions. So, to maintain blood pressure in certain parameters, the heart, blood vessels, kidneys, adrenal glands, lungs, and various other organs are involved. They all communicate together using hormones and messengers that tell each other what to do. On top of that, they also receive signals from the brain, both directly and indirectly. And the same goes for maintaining the body's fluid balance, meaning how much water we have on board in addition to the acidity and alkalinity of this fluid. So kidneys, adrenal glands, heart, lungs, and gastrointestinal tract all work together to achieve this goal. Again, the brain does have a say both directly and indirectly in this, through releasing hormones that tell the kidneys whether to retain water or not. Various salt levels in the body are regulated to minute degrees. This is achieved by an orchestra of collaboration between the kidneys, adrenal glands, the gastrointestinal tract, bones, and other organs. Again, the brain does have a say directly and indirectly into the matter. The same applies to regulating sugar levels in the blood. The stomach, intestines, pancreas, liver, muscles, fat cells, and the brain all regulate our blood pressure. The brain can do that by regulating hunger and satiety signals, feelings of fatigue or being energetic, and by sending signals to the aforementioned organs. The same applies to regulating energy levels and gene activity, meaning which gene is responsible for which functions are activated and inactivated. For example, to build muscle, we need to activate the mTOR gene, which is activated in response to tension in the muscles. Once it's activated, it will command the muscle to build itself for the next few days if the right environment is sustained. For example, if there's enough protein around. Now, to make matters even more complicated, all these various functions are indeed linked together, and they rely on each other to achieve their goals effectively. And all of it is directly and indirectly affected by what happens in our brain. For example, chronic stress can increase blood pressure, make the body retain sodium and fluids, slow down digestion, increase sugar levels, and arrest muscle-building activities. This orchestra of regulating various parameters is referred to as homeostasis, or the state of balance. The body always tries to maintain its state of balance, and various systems will come into play to compensate if one system starts to fail. There is one rule, though, that all organs agree on. Their functions should be done in the most energy-efficient way, unless there is an evolutionary advantage to ramp up their energy usage. In the next video, we will talk about why our bodies evolved in such an energy-efficient manner. For now, though, let's talk about control. What factors are in our hands to control and what factors we don't? When you first look at the question of control, we realize how little control we actually have over our own bodies. It's actually a bit unnerving. We can divide the body's control over 3 categories: voluntary control, involuntary control, and shared control. We have almost full control over the use of our muscles, sphincter control, meaning urination and defecation, and our conscious thinking. On the other hand, we have no control over how hard the heart wants to pump, or if our blood vessels want to relax or constrict, or how our stomach works, or how much bile the liver produces. We also have no control over our fat cells. We cannot tell the fat cell to store fat or let go of its fat stores. Also, we have no control over the part of our brains that regulate bodily functions. The brain just does it. Another thing that we have no control over that the brain does is our subconscious thinking. There are always thoughts, feelings, desires, cravings, and a bunch of other things that seem to just happen. An emotion can pop out of nowhere, or a thought, or a song, or a smell might rekindle a memory. They all seem to just happen without our control. Now, the last category is shared control. Some organs have a default background running mode, but you seem to be able to directly regulate it if you so wish. For example, breathing. The lungs seem to always know how much they should breathe for you. You're not even aware of all the calculations and factors that your body is going through to decide how many breaths it should take for you per minute. At the same time, you have complete control if you decide on taking over. This could be quite useful, for example, if you are planning to dive and take a deep breath first. The brain also has parts of it that fall under this category. 2 things come to mind here. What sensory processing refers to is our vision, hearing, sense of touch, and all the information our 5 senses gather for us. You can choose where to look. You can even choose to home in on a specific thing in your field of vision, but you have no direct control over how much information your eyes gather. For example, you can choose to look at this screen and focus on it, but your eyes are still gathering information about everything else around it. For example, the wall behind the screen, the table your computer is on, if there's a person in the room, etc., etc. The brain collects these information, then you decide to let go of them or not. The same thing goes for your hearing or your sense of touch. You can choose to touch something and home in on it, but even as you sit on this chair that you are currently sitting on, the skin touching the chair is relaying a flood of information to your brain, and your brain senses it. Soft, hard, cold, warm, and you choose to let go of all of this information, or you can choose not to. As long as you are alive, your senses are collecting information, and you have a choice where to zone in on this information or not. The same could be said about our subconscious thinking. There are always thoughts, cravings, and emotions coming and going through our brain, and it's our choice to zone in on what we choose. So to summarize, we have no direct control over most of the functions of the organs of our body, even our brain. We mostly have no direct control over most of its functions. But that's the thing. Although we don't have direct control, we do indeed have indirect control. So let's clarify this a bit further with some examples. When it comes to the heart, the resting heart rate is always the lowest possible to conserve energy. The heart, however, can increase the force of its contractions and the rate of how many times it pumps per minute if the body's demand for oxygen increases, such as happens in exercise. Heart rate and the force of contractions are regulated by signals from the central nervous system. Also, when we exercise, the heart muscles and the blood vessels undergo changes. Think of them as renovations to prepare you for the next time you need them to work harder. We do have control over how much we decide to exercise or not, but we have no control over how the heart will behave or adapt, but we do know that it will happen. We can also choose not to do things that will harm our heart and our blood vessels, such as smoking and eating a lot of saturated fats, since these do clog up our arteries. These are all decisions that we can take to make sure the heart and blood vessels keep serving us at their top shape. Another example of such an organ that we have indirect control over is the liver. We have no say over how much bile the liver produces, or how it helps regulate blood clotting in case of injury to stop bleeding, or how it stores energy or processes cholesterol, or help regulate blood sugar, or how it deals with all the nutrients that are absorbed from the gut and dealt with prior to sending them to the bloodstream to the rest of the body. We can, however, help out this array of functions by avoiding alcohol, eating less sugar, and avoid excessive fat intake. Now, this is an unfortunate slide. Adipose tissue, or fat cells. We have no direct control over them. Wouldn't that be nice if we have direct control over how much fat they release and burn? The fact is that we have no control that fat cells store excess fat in the blood. We also have no direct control over if and when fat cells release their fat for us to use in states of energy deficiency or exercise. We cannot change the fact that fat cells store fat in response to certain hormones, such as insulin. We also have to live with the fact that when fat stores decrease, fat cells produce less leptin, and as the brain detects it, it tries to reverse this by decreasing our metabolic rate and increasing our appetite, all to protect and try to recoup our precious energy stores. Having said all that, we do have indirect control by avoiding excessive caloric intake or large sustained energy deficits that plummet leptin levels. We can do regular exercise to keep the state, maintain healthy sleeping habits, and manage our stress in healthy ways. All these come into play to help regulate the functions of our fat cells.
Now, the question that poses itself is, where is the weight loss organ? I mean, after all, we're talking about energy conservation, energy storage, and which is the exact opposite of what we are after in the case of weight loss. And the reality is that, yes, we do have a weight loss organ. Or to be more specific, we have part of an organ which is responsible for weight loss.
Out of all of our organs, only part of our brain, which is the prefrontal cortex, is responsible for deciding and then going on to implement weight loss. The rest of the brain, and our whole body in fact, is heavily geared towards energy storage and energy conservation. In fact, the rest of your body thinks it's a completely silly and ridiculous idea that you're trying to lose weight. After all, this is what millions of years of survival experience has taught it. To understand why that is the case, we need to look at our past, our history as a species. This marvelous story will be the topic of part 2 of this video.
So to summarize, we are trying to uncover the language of our bodies. I tell my patients frequently that sustained long-term weight loss is a negotiation between the prefrontal cortex, between the brain essentially, and the rest of the body, and the body's energy conservation, essentially, protocols. So it's important to appreciate the body's language in order to negotiate effectively with it. So what we learned in this video is that the human body is composed of many organs. They function independently and interdependently as well. But they all agree on the importance of conserving energy. They all agree on the importance of doing their functions efficiently with the least amount of energy essentially possible. And for the most part, we have no direct control over them. They function according to genetic protocols that have been polished over millions of years to conserve energy. In part 2 of this video, we are going to take a look at why that is the case. Why have our bodies evolved in such a way? And how we can use this information to benefit us on our weight loss journey.